Welcome everyone, I'm Adam. In this problem, for our given vectors u with components 6, 7, and v with components 1 and 4, we're going to be finding the projection of u onto v, and then the vector component of u orthogonal to v. So first let's remember what these projections and orthogonal components mean and where they come from. So in our xy plane, if we just consider, say, two vectors in component form, so starting at the origin, so let's say we have some vector u and some vector v. Okay. Looking at our vector u, we can write this as the sum of two separate vectors. So we can find some other vector going in line with v, which we'll call w1, and another vector orthogonal to v, which we'll call w2. And w1 is such a length such that if we add w2 to w1, adding w1 and w2, if you remember this fun game we used to play when you're adding vectors in the beginning, we can just take tip to tail, move the vector w2 to the tip of w1, and it takes us to where u would go. So u can be written as the sum of these two vectors. Now the vector in line with v, or parallel to v, is what we call the projection of u onto v. And the vector w2 is the vector that's, or the vector component of u that's orthogonal to v. So part A is finding w1, and part B is finding w2. So that's where we'll start. With part A, is finding our w1, which in symbols, that's the projection, right, of u onto v. And how do we find that? Well, that's taken as the quantity of the dot product between u and v divided by the magnitude of v squared, and that's times v. So paying attention to this formula, we remember if we have a dot product between two vectors, that's a scalar. And the magnitude of v is a scalar, so squaring that is a scalar. So really what's going on is a scalar multiplication with the vector v. So all we have to do is find this thing on the left here, u dot v, and then the magnitude of v squared. Okay, so let's start with u dot v. So a dot product, right, is just the component-wise multiplication between two vectors and then adding everything along. So we're going to take the component 6 times 1 and then add it with our component 7 times 4. And then the square of the magnitude, well, the magnitude is the square root of the sum of squares of the components of v. So the square root of 1 squared plus 4 squared, but we're squaring that magnitude. And then we're going to multiply this with our vector v, vector with components 1 and 4. Okay, so let's just simplify this. So 6 plus 7 times 4, does that give us 34? And squaring our square root, those will cancel, so we just have 1 squared plus 4 squared, which gives us 17. So 34 divided by 17 is going to give us just the scalar 2 times our vector v with components 1 and 4. So being scalar multiplication, multiply the components by the scalar. So we have the vector 2 times 1 is 2, and 2 times 4 is 8. So this is our vector w1, or the projection of u onto v. So now what we want to do is, for part B, like we said, now we're going to find the vector component that's orthogonal to v, or namely w2. So how we can find that? Well, we're just going to use the fact that u is equal to w1 plus w2, or w2 would be equal to u minus w1. Well, if we know w1, or the projection already, this is a pretty easy formula, and we know u, of course. So w2 equal to our vector u with components 6 and 7 minus our projection vector W1, which we have with components 2 and 8. And so vector subtraction is just component-wise subtraction. So it's going to be the vector with components 6 minus 2 and 7 minus 8. Or giving us 6 minus 2, positive 4, and 7 minus 8, negative 1. So there's our W2 vector, or the vector component of U orthogonal to V. Thank you very much.